Okay, students, today we are going to study the most advanced, most important topic as per the current situation. Okay, those days have gone where easy questions were asked. Nowadays, it is the toughness increased because number of times the exam is conducted. So, in search of the new questions, so the depth of the question also increased. Okay, and here today we are going to study one of that such topic. That topic is HCP. What is the topic? HCP. Okay, so in HCP main problem is that the solid state is a three-dimensional. So the students are facing the difficulty. Students are facing difficulty in understanding by reading from the books. Okay, by reading from the books, it is not able for them, and for that only this answer. Okay, HCP is explained with the clear diagram. It is going to be explained to you with the clear diagram. Okay, so this is the clear diagram of one unit cell of HCP. This is one HCP unit cell. Okay, for some more clarity I am going to give you the description of each and every lattice points. Okay, so this HCP got three types of lattice points. How many types of lattice points? Three types. Okay, three types of lattice points. Okay, LPT means lattice points. HCP is going to contain how many lattice point? Three types of lattice point. Understood? So integer type, you have to be very careful with the words. If he is asking number of types of lattice point in HCP, then what you'll write? Three types. Okay. What are those three types? First is corner. What is the first one? Corner. Second one is face center. Okay. Face center. Third part is inside body. They are not actually body center. They are inside body. Because body center can always be how many? Only one. Okay, so inside body there will be three. Okay, they are deep inside the surface, so there is no sharing. That I am going to explain you further also. If the question in integer type, don't get confused with the English wordings. Understood? Number of types of lattice point in HCP. What is answer? Three. How? Corner, face center, and inside the body. Understood? So here for clarity, I have represent this with the blank circle. Okay, blank circle. How many blank circles you are able to find? 12 corners. How many corners? There are 12 corners. Okay, 6 are above and 6 are below the corners. Is it understood? Total number of corner lattice points. Total number of corner lattice points are how many? Total number of corner lattice points are 12. Okay, where they are 12? 6 in the above plane, 6 in the below plane. Okay, and total number of face centers. Corners, I think number of face and number of corners, I think everybody understood. Okay, then coming to the face centers, there are only two face center. Okay, how many face center? Two face centers only. Is it understood, students? Then coming to after the face center, body center is not there. Inside the body, there are three. Three are there inside the body. Okay, three are there where they are inside the body. Is it understood? So these are the types. These are the number of atoms number of atoms in each unit cell. So very carefully you should understand. If the question is number of atoms in each unit cell is different, per unit cell is different. Okay, total number of lattice point in a unit cell is equal to 12 plus 2 plus 3. Okay, total how many lattice points are there? They are going to be 17. How many they are going to be? They are going to be 17 lattice point. 12 are at the corner, 2 are at the face center, 3 are inside the body. Therefore, total 17. Okay, and there is a word called as rank. there is a word called as what? Rank. I am not talking about the rank which you get after the entrance examination. This rank is something else. Okay. So that this rank, if you know, your rank is going to be very good. Z is called as a rank. Okay. So sometimes it is also called as number of lattice points per unit cell. What it is called as? Number of lattice points per unit cell. It is also sometimes termed as number of lattice point per unit cell. Okay. So type of lattice points 3, number of lattice points in a unit cell 17. Now we are going to study the word number of lattice point per unit cell. Okay. So for studying the number of lattice point per unit cell, I will tell you the contribution. There is a word called as what? Contribution. Okay. So in contribution, there is no problem with the any other lattice point, but problem students are facing with the contribution of corner. Okay. Whenever there is a word corner, people are habituated that contribution will be 1 by 8. But here it is not 1 by 8. Is it understood? It is something else. So how it is and what it is, for that I am going to explain with the diagram. Is it understood? So now suppose if I am taking this corner, okay? So this is a lattice point of this, and this is the lattice point of the next unit cell. This is the lattice point of the next unit cell. Okay. So this and this 3 unit cell are having this common corner. Okay. One corner, one corner is shared by, one corner is shared by how many unit cells? 3. But we are thinking about only in one plane, and above this also there will be two more, one more layer will be there. In that layer also, how many lattice points will be there? 3 more lattices will be there. Okay. So this corner is shared by 3 unit cell of this layer, bottom layer, and above layer 3. Above 3 and below 3. Total how many? 6. One corner is shared by 6. One corner is shared by how many? 6. Therefore, contribution is not 1 by 8. Contribution is how much? 1 by 6. Why it is changing? Because in the cubic unit cell, each cube is surrounded with 3 more. So total 4 cubes will be in one layer. But it is a hexagon. In one layer, each corner is surrounded by how many? 3 only. So that was 4 into 2. Now it is 3 into 2. That is difference. Is it understood? So contribution of corner in 3-dimensional HCP is how much? 1 by 6. Okay. Now let us see about the next time. Should I erase this? I think everybody drawn this diagram. If you are not able to draw it, don't worry, because in entrance examination you need not to draw it. You have to just put mark only, click on it. Understood? Nowadays all examinations are smart, so just click away. Your success is only just click away. If you click at the right point, you are clicking in your life. Okay. Now let us, I am erasing this, take a screenshot. Otherwise you can watch it same again and again in the YouTube also. This lecture is available for all, for every time. Okay. In the YouTube. Understood? So in the YouTube you can read it. If this concept is not clear in one go, you can read it again and again. Understood? Now this HCP. I told you 12 at corner. 12 at corner. So 12 into contribution is how much? 1 by 6. So it is going to be 2. Now I am talking about number of lattice points per unit cell. See this per unit cell. Okay. Per unit cell is more important. Okay. So per unit cell, if it is there, how to calculate and what is the answer, I am going to tell you. 12 at corner, this how already we have studied. 6 at the top and 6 at the bottom, total 12 at the corner. 12 into 1 by 6 is equal to 2. Then 3 inside body. 3 inside body. So they are inside, so therefore there is no sharing. So contribution will be 1. No sharing means contribution is 1, not 0. No contribution is not 0. No contribution, no sharing is contribution is 1. Okay. Then after that, two face centers. Two face center. Face center, there is no change in SCP, there is no change in HCP. SCP is different, HCP is different. I am not talking about SCP. Okay, SCP is different, and here I am talking about CCP. Here I am talking about CCP. How many CCP are there? Two CCP are there. One is called as square close packing. Okay, then here it is hexagonal close packing. This is three-dimensional square close packing. This is also three-dimensional square close packing. Okay, this is three-dimensional hexagonal close packing. This is three-dimensional square close packing. CCP means cubic close packing. Okay, so why they both are collectively studied together? Why? Because their packing fraction is same. Okay. Now two face center, 2 into contribution is 1 by 2, therefore it is 1. 2 plus 3 plus 1. Total how many? 6. Number of lattice points per unit cell. Number of lattice point per unit cell are how many? 6. So this is denoted with Z, and it is also called as rank. Rank of HCP unit cell is 6. So while answering the number of lattice points, you have to be very careful. Number of type of lattice point in HCP. Answer is 3. Number of lattice points in a unit cell. Answer is 17. Number of lattice point per unit cell. Answer is 6. See, a single word changes your answer. So instead of getting plus 4, if it is a non-integer type, you will get minus. So avoid that negative marking. For that, you have to be very careful. Okay. Now coming to the coordination number. What is the next one? Coordination number. Coordination number. For coordination number explaining, for easiness what I am taking a face center. This is a face center lattice point. What it is? Face center lattice point. So face center lattice point is surrounded by 6 lattice point in the same plane. These are the 6 lattice point belonging to the same plane. Are you understanding or not? They are all in the same plane only. They are all in the same plane. Okay. Now, three lattice points will be above, that is inside the body. Between these two, there will be one. Between these three, sorry, there will be one. Between these three, there will be one. Okay. So this will be above this. Suppose this is here. This is a hexagonal plane. This is above plane. Okay. It is consisting how many? 3 lattice points. This is consisting how many? 6. 1, 2, 3, 4, 5, 6. 6 neighbors in the same plane, and 3 neighbors in the above plane. 3 neighbors in the above plane. Same way, 3 neighbors in the below plane also will be there. 3 neighbors will be where? In the below plane. These are the 3 below. Okay. So I am considering this. 3 will be in the same plane, and sorry, 6 will be in the same plane. 3 will be in the above plane. 3 will be in the below plane. So total how many? Total will be 6. 3 plus 6. Okay. 3 above, 6 in the same, 3 below. 6 neighbors in the same plane, 3 neighbors in the above plane, 3 neighbors in the below plane. So total coordination number is 12. This is what the difference. Okay. In HCP, coordination number is how much? 12. How it is it understood? Out of the 12, 6 neighbors in the same plane, and 3 neighbors in the above plane, 3 neighbors in the below plane. So total number of coordination number, total number of nearest neighbors are 12. Okay. Now let us study about the Packing fraction. For packing fraction, what we require is we require two types of volumes: volume available and volume occupied. In other cubic closed packing, in cubic structure, cubic unit cell, there was no problem with the volume occupied. Okay. Packing fraction. What is the formula? Volume occupied divided by volume available. Volume available. So here problem lies only in volume available. Volume packing, volume occupied is very easy. What is the formula for volume occupied? Z into 4 by 3 pi r cube. This is very easy. But volume available is only the main problem. It is just opposite to the situation what we face in cubic unit cell. In cubic unit cell, volume available is very simple. What is the formula? A cube. But it is not here because it is not a cubic structure. In cubic structure, A cube is the volume available. But in HCP, what you have to do, you have to make it in the other way. You have to make it in the other way. Okay. Here volume of HCP calculated with the different formula. What is the different formula? Area of base into height. Area of base into height. Okay. So in HCP, each base can be further divided into six equilateral triangles. They can be divided into how many? Six equilateral triangles or not. So in place of the base, what I have written, 6 into area of each triangle. Each triangle is repeated how many times? 6 times. So this will become as a area of base. So area of base is equal to 6 into area of each triangle. This is up to here it is understood. Next, height. Height will be, when you see it properly, there will be similar structure at the height, top also. What I will do, so this is one hexagon above, this is one hexagon below, but below, between this there will be a triangle. So because of this, this can be divided as a triangle like this. This can be divided as a triangle like this. This is called as a height. What it is called as? It is called as a height. Okay. So 6 into area of triangle formula is simple, root 3 by 4 a square. A is what? Distant 2r. That also you can remember. A is equal to what? 2r. Because this is one lattice point, this is another lattice point. This is edge length. What it is called as? Edge length. So I will draw it like this. So this is one a corner, this is another corner. Up to here it is A, and A is formed of the two radius. A is formed of the how many radius? Two radius. When two radius are connected together, it is going to give you one edge length. Next, so 6 into root 3 by 4 a square. Coming to the height. Height, why it is 2, is it understood? Up to here only. This is one triangle, this is another triangle. So from here to here, this distance is from here to half of the midway of these two lines is equal to root 2 by 3 a, and multiplied by 2 so that we can get complete height. Up to here it is root 2 by 3a, above this root 2 by 3a. So it will be 2 into root 2 by 3a. So total volume occupied by HCP, sorry, volume available by HCP is 6 into area of a triangle into height. So area of triangle is substituted, height is made into two equal parts. And relation between A and R is required when you completely calculate about the packing fraction. When you completely calculate about the packing fraction, as of now it is not required. Is it understood? So this is the volume of HCP. Now simply, what is the next formula? Volume occupied. Volume occupied, just now I told you, Z into 4 by 3 pi r cube. What is the formula? Z into 4 by 3 pi r cube. Z number of lattice point per unit cell, or it is also called as what? Rank. What is the rank here? 6. How we got? Already I explained. Now 4 by 3 pi r cube. Now when you divide both of them, the problem arises. What is the problem? In the numerator, this will be in the numerator, this will be in the denominator. So when you find out packing fraction, neither a should be there nor r should be there. For that, what you will do? Either in place of a you can write it as a 2r, or in place of r you can write it as a 2a. So in place of r either 2a, or in place of a 2r, but don't make it both of them. Okay. So when I will give you the substituted formula, then you can understand it very easily. Okay, on substituting, what is this? This is volume available. What is this? Sorry, volume occupied upon volume available. This is volume occupied. And on simplifying the above in the previous screen, I have told you volume available. Okay. On simplifying, this is what you will get. Volume available. This is volume available. This is volume occupied. On simplifying, you will get pi by 3 root 2. What you will get? Pi by 3 root 2. Nowadays, days are not good. Sometimes options may be in terms of the pi also. So better you remember packing fraction in terms of pi also, so that you can directly answer pi by 3 root 2, and it is equal to 0.74 on simplification. If packing fraction is there, it is 0.74. If packing efficiency, if the question is packing efficiency, then what you will do? You will multiply it with 100. Then you will get as a 74%. Okay. So if question is about the packing efficiency, your answer should be 74%. If question is about the packing fraction, answer should be 0.74. If question is about the packing fraction in terms of pi, the answer must be pi by 3 root 2. So these all about the HCP. In HCP, again I am just revising, quick revise. What is Z? 6. Okay. What is Z? 6. And number of coordination number is how much? 12. Okay, coordination number is 12, and these are the packing efficiency, packing percentage. I think all of you understood now. Just go through it, and I will give you my handwritten multicolored PDF to you. Okay, for that there are certain conditions apply. Your sincerity is required. Okay, be in contact with me, that is VIJ CHEM. Bye bye.